Hopefully, yes. Some of you did it. All right, so with that in mind, does anybody have a specific one that you have a question on? Olivia? Yeah, this one's really cool. All right, so for 37, it says a large stained glass window is constructed from 6 30, 60, 90 triangles as shown in the figure. What is the height of the window? So do we agree we're just looking for this right here, correct?
Yeah.
So we're going to start by finding these particular 30, 60, 90 triangles. So are you okay with this being 30?
Yes.
And that's 30, 30, 30, all the way around, correct? Do you agree with that?
Yes, I do.
Okay, so because of that, that would make this 1.5. Right, and let's just go ahead and make it 3/2. Do you agree with that?
Yes, I do.
Okay, so because of that, all right, that is the 60-degree side. Do you agree with that?
Yes.
So you're supposed to say, okay, if I have the 60 to get to the 30, I just do what?
I'll divide by radical 3.
Yeah, we're going to divide by radical 3. All right. So if I divide by radical 3, that becomes 3/2 radical 3. Do you agree with that?
Yes.
Now, from there, I have to find this piece of the puzzle. Do you agree with that?
Yes.
So then I would multiply that by 2. Do you agree? To get from the 30 to the hypotenuse, you multiply by 2.
Okay.
Right? So now this length right here is 3/radical 3. Do you agree with that?
Yes.
Okay. Now it's the same principle, right? So I'm at the 60-degree of this triangle. Do you agree with this?
Yes.
So the hypotenuse of one is the 60 of the other. So now I have to go from the hypotenuse over to the 30. So I'm getting smaller, so I'm going to divide by radical 3 again, right?
Right.
If I divide by radical 3, that will just create this as a 1. Do you agree with that? Now, how do I get to the hypotenuse of the green triangle?
Multiply times 2.
That is correct. So multiplied by 2. Now I have to get to the 30-degree side. So what do I do now?
Multiply by divide by radical 3.
Right. So this length right there is 2 divided by radical 3. Right?
Right.
And so how do I get to the height now?
Multiply times 2.
Right. So the height is equal to 4 divided by radical 3. But we're not going to leave it as 4 divided by radical 3 because we are brilliant. We're just going to say 4 radical 3 over 3. All right. Now, honestly, if you know that, then we're just in great shape. Yeah. Let's continue on.
Wait. Is this a right triangle?
All of these are right triangles.
Yeah, so when you have to square the two numbers,
I don't know what you're saying square for.
like the length of the hypotenuse.
Do you remember any of the rules for 30, 60, 90 triangles?
No, not really.
That's why you don't know how to do the problem. It's a 30, 60, 90 triangle. At the top of your notes, I told you exactly how to work with 30, 60, 90 triangles and 45, 45, 90 triangles. Do you see it up there? If you didn't know the 30, 60, 90 triangle rules, you couldn't do any of this. Because it only gave you one side. Harrison, I don't know if you're listening to me. We know this right here, that's it. I can't do a squared plus b squared equals c squared with one number. Harrison?
Yeah.
So do you know the 30, 60, 90 rules? And we did it on Thursday, so I understand if, you know, it's been forever. That's why I don't like taking breaks. Do you have the notes up at the top of your paper? Okay, so you should have on your notes from 90 to 30, you divide by 2. From 30 to 60, you multiply by radical 3. Then if you do the reverse, if you go from 30 to 90, you multiply by 2. And from 60 to 30, you divide by radical 3.
Okay.
That's what you're supposed to know.
I don't have the 90 to everything. So
Okay. From the 90 to the 30, you always divide by 2. All right. So now someone asked me about 38, right? All right. So can someone tell me what this length is right here? Just based off of the figure. Very good. X. How did I know it was X?
it is the same.
Yeah, it's a 45, 45, 90 triangle. Now, just because I want to see if you're paying attention, what is this length right here going to be?
Yeah.
Nope.
Exactly.
X radical 2. Now, what is this length right here going to be? I don't think so. 2x, thank you very much. It's 2x. Now, does anybody have any problems with that?
Why is it 2x?
Because you see the big triangle, right?
Mm-hmm.
It's a 30, 60, 90 triangle. The hypotenuse is always twice whatever the 30-degree side is.
All right.
Makes sense now, right?
Mhm.
So I have a relationship for all the sides now. How high is the top of the screen in terms of X? What do we got? So does everybody agree it's just X? All right, so the answer here for A was X. Okay, so now, what is this length right here? Anybody tell me what that length is going to be?
X plus 15.
That is X plus 15. Now, this is hard, okay? So I'm not having a, what is that also? What could that also be equal to? X radical 3. You are amazing. Thank you. Bless you very much. Hey, thank you, JD. So now, what do I do for X plus 15 divided by X? Somebody tell me what that is. Say it again. You are amazing. Radical 3. Now, how do we know that? So look right here, guys. See this equation? So we knew that x plus 15 was equal to x radical 3, right? I'm looking for x plus 15 divided by x. So I just divided by x. That was actually very good. X plus 15 divided by x is radical 3.
Why is x plus 15 for x radical 3?
Okay, so let me ask you this question, Harrison. That's a good question. Can you tell me what this distance is from here to here?
Yeah, x plus 15.
It's x plus 15, right?
Yeah.
So now I'm asking you, look at the big triangle. Leave the x plus 15 alone. The x plus 15 is not there. Here's what I have. All right, so what I did was I tried to make this triangle. That was pretty good. I tried to make that triangle the big triangle. This right here is x. So what is this?
Oh,
Keep in mind, this is 30, this is 60, this is 90. So
so it's x radical. Oh,
now you're with me. Nice, right?
yeah.
Very sneaky. Very, very sneaky. All right, very sneaky. So now I'm just looking for x. Does everybody agree with that? Everybody agreeing?
Yep.
So here we go. X plus 15 equals x radical 3. All right, now we're reviewing for your upcoming test if you're going to Berkeley or, private school, or you have to know some algebra. All right. Now, I'm trying to solve for x. Whenever you're trying to solve for x, you have to get x on the same side. So I want everybody to say 15 is equal to x radical 3 minus x. Is that good? Anybody have a problem with that? Putting the x's on the same side. Now that x's are on the same side, you have too many x's. You only want one x. So you have to factor out an x. So 15 equals x parentheses square root 3 minus 1. I just factored out an x. And so now somebody tell me, what does x actually equal? Come on, someone tell me. X equals, I'm isolating the x. Thank you. 15 over radical 3 minus 1. And that's your answer. That's what x equals. Now, let's do an approximation. All right. I'm trying to see if you can use your calculator properly now. So I want everybody to type that in the calculator and see if you can come up with the right answer. What did you get approximately? Somebody said 7.66. No, you guys aren't right.
You got 20.49
Yeah, that's what I got. 20 point what?
or 20.5.
About 20.5. Now, that's part of the reason why I wanted you to do it on your calculator, because you need to do 15 divided by parentheses square root of 3 minus 1. Or you can do the math fraction button. And when it comes up, you don't have to do the parentheses if you put it like this. So make sure you can get that on your calculator now, guys. Anybody else? Everybody's got to try it now. Make sure you know how to use your calculator. Anybody have any issues with that? Okay, now I know I said I wanted the whole thing done, so I want some more questions if you have it. I think it's important.
I still get how x plus 15 equals radical 3.
I didn't hear you.
I still don't get how x plus 15 equals radical 3 from numbers.
We just divided this equation by x.
Where did you get x radical 3 over x?
That's what we just said was true. Do you agree or not? We said that's true, right?
Yes.
So I just divided both sides by x. And what happens to the x's?
It gets one.
And that's why x plus 15 over x equals radical 3. That was hard. I agree. Tell me.
Do 36.
36. Okay, so the hexagon is on most standardized tests. And the reason why the hexagon is on most standardized tests is because when you divide it up, what kind of triangles does it make? Well, actually, it makes, if you just draw it like this, tell me again. Yeah, they're equilateral. If it's regular, all right, if it's a regular hexagon, right, we know this is 60. And regular means that's equal. So it creates 6 equilateral triangles. And because it creates 6 equilateral triangles, each triangle, if I were to draw the altitude in, would cut it into what type of triangles? No, 30, 60, 90, right? Because the 60 would be cut in half and this still remains 60 and this is 90. So what you need to remember is that when you take a hexagon and cut it up, it creates 30, 60, 90 triangles. All right, is everybody good with that? Okay. So if the side length of the hexagon is 3, what are the dimensions of the rectangle? All right, so let's knock this out. So if this is 3, each side is what? Of the hexagon? 3. What's the radius going to be? Also 3, right? So can somebody tell me what the width of the box is going to be? How much from here to here? Sorry, let me make sure this is clear. How much from here to here? Somebody tell me. 6, thank you. Because it's the same as what? This right here. Everybody good on that? Right now, again, the reason why I'm spending a little bit of extra time on this is because the SAT, the ACT always have 30, 60, 90 triangles. All right. So does everybody agree the width of the box is 6, correct? All right. So now I'm going to erase a little bit here so it's not confusing. All right. So if this is the center from here to here, from here to here. Now, this distance, someone tell me, from here to here is how much? 3, right? So how much would this distance be right here? 1.5, right? Then what would this be right here? Yeah, it's just a pattern, guys. It's just 1.5 radical 3. All right, this is 1.5 radical 3. So what's this length right here? Somebody help me. What's this one right here? What is this length right here? Exactly, exactly. Thank you. It's the same as this. It's the height. So that's 1.5 radical 3. So then someone tell me with certainty what this is from here to here. 3 radical 3. Thank you. That was good. 3 radical 3 by what? 3. I'm sorry, not by 3, but by what? Sorry about that. That's 6. Thank you. 3 radical 3 by 6. Anybody have any questions? That was kind of hard. Somebody else who took some time. Anybody want me to do anything else? Yes, sir. Let's look at 35. A 40-foot long escalator rises from the floor to the second floor of the shopping mall. The escalator makes a 30-degree. How high above the first floor? So this is what we have right here, right? Makes 30-degree angle, right? And it says a 40-foot long escalator. So I'm assuming this is 40. So now that we drew it, what's this? Somebody tell me quickly. 20, right? Everybody good? And if for some strange reason they ask for this, it's just what? Say it. 20 radical 3. Now, does anybody feel they need me to review the rules for the 30, 60, 90? I really don't mind. I know it's been a while. Does anybody feel like they need to review the rules? Anybody else want me to do something on this worksheet? Anybody? Because I'm going to collect it now. Let's look at 16 real quick. Well, now we know how to do it because we just did equilateral triangles, right? So if you draw an equilateral triangle, try to. That looks like an equilateral triangle to me. And the altitude is 36, right? So that means from here to here, that's 36. Do you agree? Now, don't forget that's the 60-degree side. Do you agree? So to get to the 30-degree side, what am I supposed to do? From the 60 to the 30. Somewhere on your notes, it should say from the 60 to the 30. Now, let's just say you don't. Look up here now, please. This is what I want everybody to understand. All right, please watch how easy this problem is. If this is X, come on. This is X. What's this distance right here, guys? X over 2. This length is X over 2. Maren, do you understand that or not? So that means this is X divided by 2 times radical 3. So to get from the 30 to the 60, I multiply by radical 3. But to get from the 60 to the 30, I would do what? That's the rule. You just have to know that. You have to know that. So now they're telling me that the altitude is 36. So if this is 36, how do I get to this length right here? Divide by radical 3, because you're going from the 60 to the 30. So 36 divided by radical 3. Then when you rationalize it, 36 radical 3 over 3, which is 12 radical 3. So half of the equilateral triangle is 12 radical 3. So then the whole length would be what? Say it again. 24 radical 3. All right, that's the length of the side. Yes, good for you. 33. Yeah, now that's the same thing.
No, I was just confused on how, like.
No, listen, I'm glad you asked me. I'm just saying now we should be better at it. All right. So you have an equilateral triangle again. And the altitude is 11 radical 3. So come on now. And again, that is 11 radical 3. So what's this now?
Radical 3 over 2.
Divided by, no, this is the 60. This is the 60-degree side. Now, some of my kids never really understood what I meant by that's a 60-degree side. Do you understand what I mean?
Yeah.
So how do you get from the 60 to the 30? Because that's where we're going. What does it say from 60 to? Right, so you just take 11 radical 3 and you divide it by radical 3. So what's that? 11. So this piece is 11. So then the whole side would be what? Because now look up and let me show you. This is 11. So what's this piece right here? 11. So the whole thing is, it's easy, right? And again, I'm saying it's easy, but if you don't know the rules, that's why you don't understand, right? That's why that is 22 feet. Anybody else? Again, I'm just telling you, it's super important for ACT and SAT to understand the rules for 30, 60, 90, 45, 45, 90. Please, anybody else on here want me to do another problem? Anybody? What?
I know the 30, 60, 90, but I don't really remember the 45, 45.
It's just radical 2's involved. So why don't you look on your worksheet that has the whole bunch of 45, 45, 90s that you didn't do and say, hey, just show me how to do this one.
Oh, wait, so you just telling me about.
To get from the hypotenuse to the leg, what do you do, guys? On a 45, 45, 90. Divide by radical 2. To get from the leg to the hypotenuse, you multiply by radical 2. That's how easy. Anybody have any issues? Anybody have any issues? All right, I'm expecting you to do a good job on that. All right, so let me just pause this for a quick second. Oh, let's. So if you are referring to angle R, then letter R is considered the opposite side. Letter S is considered the adjacent, is what they call it. All right. Now, some people, for some reason, get things all confused. All right. Is it possible to get the hypotenuse confused? No. All right. So to me, I always put down H for hypotenuse first. Then I choose the opposite, because to me, opposite was easy. The opposite side of the angle is what? R. So the other side had to be the what? Has to be the adjacent. So bear with me on that. All right. So from R's perspective, the definition of sine. So everybody's going to put down sine. And after your trig function, it's always the angle. You always write the angle. So sine of R is defined as opposite over hypotenuse. Now, what letter corresponds to the opposite? R. And what's the hypotenuse? T. All right. Cosine's definition is equal to adjacent over hypotenuse. So if I was wanting the cosine of R, it would be what? S over T. That would be correct. And then the last one, the last trig function, is the tangent of R, and the tangent is defined as opposite over adjacent. Opposite over adjacent, which in this case is R over S. Now, that's crucial. Those are just the definitions. All right, those are just the definitions. So let's abbreviate. S O H C A H T O A. All right, so they give credit to Sakatoa for inventing trigonometry. Sakatoa, all right? SOHCAHTOA, Sakatoa, all right? That's the abbreviation, all right? Now, obviously that's something silly, but that's supposed to help you memorize, all right? If you go to plant next year, all right, or any of the public schools, they will say Sakatoa is some old hippie caught another hippie tripping on acid. That's what they would say. All right.
Oh, true.
Some old hippie caught another hippie tripping on acid. That's if you go to public school, that's what they will teach you.
Let's
All right.
go.
All right. Those of you guys who go to private schools, they will say it's some sacred Indian that developed trigonometry, whose name was Sakatoa. All right. So that's what we got. I don't care how you do it. All right. I just need you to know that sine, all the trig functions are just ratios. All right. Now, believe it or not, before we had calculators and before we had computers, this was all done by hand. All right. And in my old pre-calculus book, we had to flip to the back of the page and look up each angle measure. All right. But when I was in 10th grade, the big deal was the introduction to the calculators. And once we had the calculators, we were all amazed because you could now just hit a button and that ratio would come up. All right. So your calculator, again, is super duper powerful. All right. So I want everybody to take a look at their calculator. And I want everybody to look above. All right. At the top of your screen, there should be a degree mode. It should say degrees. If it says radians, I need you to tell me. Does yours say radians? All right. So if it's in radians, that you will learn in pre-calculus. All right. So because we're going to be working in degrees, we need to set our calculator to degrees. So I need everybody to hit the mode. Everybody hit mode. And then one of the first things that comes up is degrees and radians, right? So you need to highlight degrees. Everybody highlight degrees for me. And if you're in degrees, now you can go to your home screen and at the top, it'll say now what? It'll say degrees. All right. So again, guys, this is critical right here. This is critical. If you understand what I just said about the definitions, this, I promise you, is super easy. Trig sounds really complicated. All right. People try to make it complicated, but it's really what? Really simple, really simple. Now, I do want to make one other quick note here. All right. I need everybody to look. Now, I gave you from R's perspective. Now, what I want to do is I want to take it from S's perspective. All right. So now here's where everybody makes mistakes. So I need you to really listen to what I'm saying. From angle S, does the hypotenuse change? No. But what is the opposite from S's perspective now? That is correct. All right. So this is why people get confused. Because you have to know from what angle are you referring to be able to tell me which one is the opposite and the adjacent. Is everybody with me on that? So from S's perspective, then R is considered the what? The adjacent. So that's where people make all kinds of mistakes. So I'm trying to tell you to listen to what I'm telling you right now, and it'll be easy. You have to be, in order to write a trig function, you will be going from one of the acute angles. All right. From that angle, I used to draw a line and I knew that would be the what? Opposite. All right. That's how simple. All right. There is really nothing to it. All right. Now, let's continue on since we just did this. All right. So now for the next part right here, look where I'm at. I'm referring to this triangle right here now. From A's perspective, remember, a trig function is just a ratio. So what is the opposite leg for A? 5. What's the hypotenuse? 13. What's the cosine? 12 over 13. And what's the tangent? 5 over 12. Now, honestly, if you can do that, right, the whole worksheet is super simple. All right, I need everybody to be able to tell me when I say what's the definition of sine, you're going to say it's a ratio of the opposite leg to the hypotenuse. If I said what's the definition of cosine, you would simply say it's a ratio of the adjacent leg over the hypotenuse. If I said what's the definition of tangent, you would simply say it's the ratio of the opposite leg to the adjacent leg. That's it. And I know everyone in here is smart enough to do that. If you don't do the work is where you get the repetition, where it's just super simple. All right. Now, I want to express all of these, and we're not going to have to do all of this, but I need everybody to understand sine, cosine, tangent, sine, cosine, tangent. So you're doing from both angles. Now, does everybody understand it is a ratio, correct? So if it's a ratio, you always reduce the fractions, correct? So here, instead of reducing last, I might as well reduce what? First. So what can I divide each of those numbers by? 4. So cross out 16 and put a what? 4. Cross out 20 and put a, and cross out 12 and put a 3. All right. Or 2 is good, whatever you want. All right. So now, again, like I said, if you can write this, you know what you're doing. So if I ask you, what's the sine of J? Everyone would tell me it is 3 over 5. If I said, what's the cosine of J? Everybody would tell me 4 over 5. And if I said, what is the tangent of J? 3 over 4. Now, right next to that, we'll go sine of L. What's sine of L? 4 over 5. What's cosine of L? And what's tangent of L? 4 over 3. That's really easy. All right, that's really easy. All right, anybody have any questions or concerns with that? Anybody? What? Who said wait? Anybody have any issues with that? Never mind. You sure, Harrison?
Yeah.
Okay, what time's the bell ring? Okay, so listen, what I will do is circle 2 just for practice, circle 3 just for practice, and circle 10 and 11. And that's all you have to do. All right, the bell's going to ring here in a few minutes. All right. But again, listen to me. I can't show you the important stuff if you don't know these definitions. All right. So again, I don't care how you remember it. All right. Lots of different ways, Sakatoa, or some old hippie caught another hippie tripping on acid. I don't care how you memorize it, but I give no formulas when you take the next test. No formulas. You have to know everything. All right. And that makes it a little bit tricky for some. All right. So tomorrow we will finish up. Then on Wednesday, we will get our review. Friday, we will take a test. Monday and Tuesday, we're going to learn 2 more sections of trig, quiz, or then we're going to have a review on Wednesday and then another test next Friday. All right, is everybody with me? And then we'll be done with this chapter. All right. Any questions? Any questions?
What's the elective that
I don't think he has school next Monday.
Yeah, that's right. That's why. Exactly. That's why you're correct. So we'll be doing Tuesday, Wednesday. We're going to review one day on Thursday, which will be just over 2 sections. So you're going to have a quiz on 2 sections. That's what it was. Thank you very much. All right, because Martin Luther King, I think, is next Monday. So we'll be doing Tuesday, we'll learn law of sines. Wednesday, we'll learn law of cosines. Thursday, we'll review sine and cosine. And Friday, you have a quiz on law of sines and law of cosines. Again, sounds complicated, but it's super easy. All right, please make sure the homework gets done. And then tomorrow, I'm going to finish this worksheet up. All right, everybody needs their calculator. All right, so now you got to be patient because I have